Hello. So today we're going to look at pseudocode and algorithms. So basically what pseudocode is, it's not really a programming language. All it is a way of breaking down a problem that we might want to write your program for into pieces. And so just to kind of learn this, I think the best way is not even to think in terms of programming at all. I'm just going to take a common task that I might do on a given day. So I'm going to, and I'm just going to use a regular text editor. You can do this on a piece of paper, whatever works best for you. So let's say that I'm going to take an action called driving to town. So that is one description. So that describes an action I might do on a given day. So then what I want to do is I want to see, well, how can I break that up? What is it that is involved in driving to town? So well, I need to go to my car, unlock the door, enter the car. What else do I need to do? Start the car, drive to town, stop the car, well, park the car, and then get out of the car and lock the car. So maybe those would be the steps that would describe what I was doing to drive. But can I break this down into even more granular parts? How do I get to my car? Well, I need to remember where I left my car. And then I can walk in the direction of my car and then stop when I get there, and then unlock the door, take key from pocket. Oh wait, if I can't get the key from my pocket, if I didn't get it, so really before I go to my car, I need to up here say get key to my car. So I need to do that first before I go there, because if car key is left indoors, I'm not going to be able to get there. So notice as I start breaking this down, I start noticing, oh, there's a piece I need to do up here before I get there. And then insert key into door, turn key, depress handle, swing door open. And then I might break this down, enter the car. Not much to add there, step into car. But I might add in here, close car door. And then lock door from the inside. I probably should add in here maybe put on seatbelt. So as you can see, as I'm going through here, I'm increasing the detail of my pseudocode, and you notice I'm actually kind of putting this in a hierarchy. I'm tabbing things in that are related. This really describes this whole process. So these are all sub-processes of each other, right? All of this fits under the idea of driving to town. And as we go in here, key into ignition, turn key. Notice that these two steps look pretty similar. So these could actually be, a separate function, which is how to use a key. And then drive to town. Well, that's going to be a little bit and if you have a manual, depress clutch, put car in correct gear, in first gear. If you're an automatic, it would just be that, or put it in drive, and then drive to town. Now this gets, very complex. I'm not going to break this down, but but you get the idea. When we park the car, we depress clutch, put car in first gear, maybe apply brakes needs to go in here. Probably a good idea to stop the car. And then, and then getting out of the car. I guess that is really in here. So now, more or less, I guess here, just for sake of argument, so obviously we don't really want to do this randomly. There's a bunch of decision things which we'll learn how to do later, but for now we'll just put that in to kind of get there. So you can see very quickly, this is a pretty complex process, but now if I look at each one of these steps, I can ignore all the others and just think about each one at a time. And later on when we're writing code, this kind of a breakdown will make it easier for us to take a complex problem and break it down into smaller pieces. In fact, from an engineering perspective, this is called a functional decomposition or work breakdown. So this is pseudocode, also known as functional decomposition or work breakdown. You can use the word functional decomposition so you can sound really cool, but really all it is just describing step by step how you do a process before you start turning it into code. So that's basically pseudocode. Thank you very much.